Okay, so now let's look at these questions from, the question number 75, 77, and then 81 and 85. So these relate to the limiting reactant and percentage yield. So I'm going to cover all four of them in this video. All right, so here we have the a reaction is given to us, nitrogen plus 3 moles of hydrogen, 1 mole of nitrogen reacting to produce 2 moles of ammonia. Okay, so one question is find the limiting reactant. Now, anytime there is a question that relates to the limiting reactant, that means you're going to compare the two reactants. You're going to compare nitrogen and you're going to compare hydrogen. And both of them will be compared to see how much of the ammonia each can produce. The one that is going to give you the less acts as a limiting reactant. So let's do that first. We're going to look at the relationship of nitrogen N2 to ammonia NH3. Next, we are looking at the relationship of hydrogen to ammonia, how much that you can get. Now here, let's calculate the molar masses. Oh, wait, we don't need the molar mass because we're just going to do moles. Okay, so that's a good thing. So now we are going to look at, start with the nitrogen first. So 3.00 moles of nitrogen. So 3.00 moles of nitrogen N2 times, let's see how many moles of ammonia you can get. So from the balanced equation, you're going to see, you see that 2 moles of ammonia are produced when 2 moles of ammonia are produced when 1 mole of nitrogen reacts. Okay, so this cancels out the moles of nitrogen. Moles of nitrogen canceled out, and you are just left with the moles of, excuse me, ammonia. So 3 times 2 is 6 moles of ammonia can be produced when 3 moles of nitrogen are reacting. Okay, so that's one. Next is with the hydrogen. Okay, hydrogen is you're given 5 moles of hydrogen. So 5.00 moles of hydrogen. Okay, 5.00 moles of hydrogen times. Now you have 2 moles of ammonia, 2 moles of NH3 over 1 mole of NH3, 1 mole of NH3. Okay, and that gives you so wait, sorry, not NH3. I'm making a mistake here. Sorry about that. Okay. Hydrogen, so it's relationship of hydrogen and ammonia. So here we have 3 moles of hydrogen. Okay, now you see that the moles of hydrogen and the moles of hydrogen cancel out, and you're just left with the moles of ammonia. So now you are going to multiply 5 times 2, 10 divided by 3. So here we have 5 times 2 divided by 3, you have 3.33. So, one second, 3.33. Okay, so 3.33 moles of ammonia can be produced. Okay, so it's not about, you see, hydrogen is larger in amount, but it is giving you lesser ammonia. You're using larger moles of hydrogen, right? But you're producing lesser moles of ammonia. So regardless, comparison, 3 moles is 3 is less than 6. So that means that hydrogen is the limiting reactant because it is producing lesser NH3. Okay, next, aluminum, the next one, aluminum with chlorine, giving you AlCl3. Now here they're giving you the grams and they need to find the limiting reactant. Okay, now what they're saying is that you take 20 grams each. So you're going to look at the relationship of aluminum to AlCl3, the product. It's always the reactants to the product, always the reactants to the product. So here you have the reactant aluminum and the product is aluminum chloride. So that's one piece. And you are given 20 grams of aluminum. So you're going to find how many grams of AlCl3 can you produce. So this is one thing. Next is you're going to look at, let's do it here, chlorine. Okay, chlorine. You are still, they are giving you 20 grams of chlorine. Then you find how much of AlCl3 can you produce? How many grams when you use 20 grams of AlCl3, how many can you produce? Okay, now, so because it's a grams thing, so we will need to find the molar mass. Let's do this. Molar mass of aluminum is equal to 27 grams per mole. This information I get from the periodic table. Molar mass of Cl2 is equal to 2 Cl times 35. That's again from the periodic table. And that is 70 grams per mole. Okay, next is molar mass of AlCl3. So AlCl3 is 1 aluminum and you have 3 chlorines. Aluminum is 27 grams and chlorines are 35 grams each. So let's see, 27 plus 35 times 3, 35 times 3 is equal to 105. So 105, and this 105 plus 27, and that gives you 132. 132 grams per mole. So this is for the AlCl3. So these molar masses are important. The general strategy you're going to use is still going to be the same. You're going to take the grams of A and you're going to convert that to the moles of A. And that is going to, then you're using the molar mass. Okay, that's the molar mass, M. Okay, next is you're going to take the mole to mole ratio. So moles of B over the moles of A. Okay, then that converts the moles of A to the moles of B. Next is you're going to convert the moles of B to the grams of B. So how are you going to do? You're still going to go through via the molar mass route. Okay, so that's a strategy. So let's do this now. Okay, so black. Okay, aluminum to AlCl3 first of all. Uh-oh, I don't have a space here. Just give me 1 second here. All right, let's do this now. So we have aluminum to AlCl3. Let's do this first, AlCl3. So 20 grams aluminum times 1 mole, let me move this up, sorry about that, 1 mole of aluminum over 27 grams of aluminum, multiply by the mole to mole ratio. So that is 2 to 2. 2. Oh, wait, 1 second. Doesn't seem right to me. This is 2. Let's see. 3 2s are 6. This should be 3. 3. Okay, 3. So 2 aluminums, 6 chlorines. Yeah. Okay, so that was a misprint. Okay, anyway, so we have 2 aluminums. No, sorry, 2 AlCl3 and 2. So it's 1 to 1, but you should still write down what you have. So 2 moles of AlCl3, and that is coming from the reaction, and 2 moles of Al. Okay, next, the grams. I mean, you can stop here, but since we've been to find the grams also, so let's do that. 132. 132 grams of AlCl3. And that 132 grams of AlCl3 is the molar mass over 1 mole of AlCl3. Okay, so that cancels out now the grams of aluminum, moles of aluminum, moles of AlCl3, and you're just left with the grams. So let's do the calculations. Okay, so here we get the 97.7 grams of AlCl3 when you use 20 grams of aluminum. Now let's find out when we use 20 grams of Cl2. Okay, so let's do this. 20, so Cl2 to AlCl3. How much do we get? So 20 grams of Cl2 times 1 mole of Cl2, okay, over the Cl2 was 35, no, 70, sorry, 70 grams of Cl2 times the mole to mole ratio. So we see that 2 moles of AlCl3 are produced when 1 mole of, sorry, how much was that? 3 moles of 3 moles of Cl2 react. Okay, and next is 1 mole of AlCl3 here, and you have 132 grams of AlCl3. Okay, let's see, let's do the math. Okay, so as you see, I canceled out all the units, and then the only, after the calculations, I'm getting from the chlorine 25.14. So 25.14 is obviously lesser than 97.7. Therefore, chlorine is the limiting reactant. And this really is the theoretical. In theory, you can produce this. In theory, this is the theoretical yield. Okay, this one is a calculated yield. Then it becomes a calculations because you will never be able to produce. So this is the calculated yield. You will not be able to produce. This is a theoretical yield. If everything you do correctly and there is 100% efficiency in your processes, yes, you can obtain 25.14 grams of AlCl3 when you use chlorine, because this is the limiting reactant. Cl2 is the limiting reactant. Okay, all right, so important questions, you know, all this is going to be on the test. Okay, next is the percentage yield. How do we calculate the percentage yield? Now in this case, always, you know, when they give you, they'll always say one of the entities is in large amount. So you are given 40 grams of carbon and we are trying to produce carbon disulfide. So here they are saying how much, what is the percentage yield? So when they give you the amount, that amount that is given is always the actual yield. This is actual. Actual means the stuff that you can obtain in the lab after doing all the processes, after finishing all the processes. The real, in reality, you would obtain this. Okay, so this is actual yield. And the formula is percentage yield is equal to the theoretical yield, actual yield over theoretical yield times 100%. Okay, 100%. Sorry, I'm just swamped with space. Okay, times 100%. Okay, so that's your formula. So in this case, actual is given. So you have to first find the theoretical yield. Okay, find theoretical. And how are we going to find theoretical? We are given one of the reactant, which is CS2. We are given, let's write this down. We are given 40 grams of carbon. So let's find out how many grams of carbon disulfide can we produce. Okay, so write down here. So here, once again, you would need the molar masses. So the molar mass of carbon is 12 grams per mole, and that of sulfur, CS2, is equal to 1 of carbon and 2 of sulfurs times times. Carbon is 12 and sulfur is 32. So here you have 12 and here you have 32 times 2 is 64 grams. Okay, so 64 plus 12, 76 grams per mole. Okay, now let's do this. Let's find the theoretical. So when we use 40 grams of carbon, convert that first to mole. So 1 mole of carbon over 12 grams of carbon. Okay, multiply that by the, so it's 5:1. So 1 mole of CS2 is produced when, wait a minute. Yeah, is produced when 5 moles of carbon react. Okay, times, look at the grams, 1 mole of CS2, 1 of CS2, and here you have the 76 grams of CS2. Okay, let me just move this here, 76 grams of CS2. When you add these, you get 76 grams per mole. Okay, that's the molar mass of CS2. All right, so now let's see how much it is produced. So we see by this, the grams of carbon and grams of carbon cancel out, moles of carbon cancel out, moles of CS2 and the moles of CS2 cancel out. So let's see. So we are getting 40, right, times 1 times 76 is equal to 3040 over 12 times 5 is equal to 60. So 3040 divide by 60 and you get 50.66. So 50.66. Now in this case, just keep it exact. Don't round up or anything. AlCl, no, sorry, not AlCl, it's CS2. CS2, it's CS2. Now, we are producing, in theory, always keep this in mind that the actual is always going to be less than the theoretical, always. Because in theory, it's all in paper, but actual is when you actually perform, you get, you achieve, you're able to get it in your hand. Okay, so now percentage yield is what? Percentage yield, YIELD, is equal to actual is 36, okay, grams, divide by the theoretical is 50.66 times 100%. Okay, so what do you get here? 36 divided by 50.66 times 100, and you get here 71.61. So percentage yield answer is 71.06, sorry, 71.06% is the answer. Okay, that's the percentage yield. All right, so this is how you're going to do, and these are the test questions, okay? Questions like this will be on the test. Okay, so grams of carbon is given to you. 30 grams of carbon is given to you. Carbon monoxide, 28.2 grams of carbon monoxide is produced. Find the percentage yield of carbon monoxide. It's the same story. You're going to first always write the formulas also, okay? So here we have the percentage yield formula. Percentage yield formula is equal to actual over theoretical times 100%. All right, now here molar mass of carbon, molar mass of carbon is equal to 12. Molar mass of CO is equal to 12 for the carbon plus 16 from oxygen. So 12 plus 16 is 28 grams per mole. Okay, grams per mole. So always do those. Next is 2 grams. So start with 3. So let's see if you're using 30 grams of carbon, then how many grams of carbon monoxide can you produce? So we have here 30 grams of carbon times 1 mole of carbon over 12 grams of carbon times the mole to mole ratio. So we see that 2 moles of carbon monoxide is produced when 3 moles of carbon are attained, and then 3 moles of carbon are being used. Then 1 mole of carbon monoxide is 28 grams carbon monoxide. So let us see what is happening here. So you have grams of carbon and grams of carbon, moles of carbon, moles of carbon, moles of carbon monoxide, moles of carbon monoxide. Okay, so what do you get here? You have 30 times 1 times 2 times 28. Divide that by 12 times 3 times 1. Okay, 30 times 2 times 28. 30 times 2 times 28 is equal to 1680. Divide that by 12 times 3, 36. So divide that by 36 and you have 46.66. 46.66 grams. So this is the theoretical yield. In theory, you are producing this much. So theoretical. Okay. Now, put it in the formula, 28.2. So percentage yield is equal to 28.2 grams over 46.66 grams times, don't round up or anything, 100% is equal to 28.2, divide that by 46.66. 46.66 times 100%, and that comes out to be 60.43%. All right, or 60.4%, depends. 60, what if you're calculating. Okay, so that finishes this, all the homework set questions. There were quite many, but I hope this was helpful, and keep practicing, because you do have several of the other problems also. If you want to practice more, those you can do those, but you can also just do these. All right. Okay. Thank you. Take care. Bye-bye.